Good day, Louisian stars. Welcome to our first grading week 2 discussion. We will have first the Cartesian Coordinate System. The Cartesian Coordinate System uses two coplanar perpendicular number lines. When we say coplanar lines, these are lines that lie on the same plane. Perpendicular lines are two lines that intersect at a right angle. And number line is a straight line with numbers placed at equal intervals or segments along its length. So this is how it looks like. Now we are going to describe our Cartesian coordinate system. The horizontal number line is what we call the x-axis, while the vertical number line is what we call the y-axis. The point of intersection of the two axes is called the origin, and in ordered pair it is written as 0 and 0. Ordered pair is a set of two well-ordered real numbers called coordinates. So it is written as the quantity of x and y coordinates. Coordinates is defined as the numerical descriptive references of a point from the two axes. Now we are going to define our x and y coordinates. X coordinate, also called as abscissa, is the first coordinate which corresponds to a real number on the x-axis. Y-coordinate, or also called ordinate, is the second coordinate which corresponds to a real number on the y-axis. Going back to the picture of our Cartesian coordinate system, notice that the two perpendicular lines have formed four regions, and these regions are called quadrants. The shaded part is quadrant 1. Both the abscissa and the ordinate are positive. The next shaded part is quadrant 2. The abscissa is negative and the ordinate is positive. Next is quadrant 3. Both the abscissa and the ordinate are negative. And for the last region, we have quadrant 4. The abscissa is positive and the ordinate is negative. So how do you plot points on a coordinate plane? First, draw an imaginary line when locating the abscissa on the x-axis. Then, draw an imaginary line in locating the ordinate on the y-axis. Take note that the intersection of the two imaginary lines is the location of the point. You don't need to draw an imaginary line if you can already plot a point by simply looking at the given ordered pair. Now let's try to locate and plot the following points on the Cartesian plane. For our first example, we have point M with coordinates 1 and 3. This point is located on the first quadrant. So here it is, point M. Second example, point A with coordinates -2 and +6. It is located on the second quadrant. So here is point A. For our third example, we have point P with coordinates -3 and -5. It is located on the third quadrant. So here is the location of our point P. Next is point H. with coordinates 6 and -4. Its location is on the fourth quadrant. So here is point H. Another, point D with coordinates 0 and -8. This point is located on the y-axis. So here is point D. And for our last example, we have point B with coordinates 9 and 0. It is located on the x-axis. So here is the location of point B. Here are all the points that we've plotted. You may visit the site for you to practice more on locating points or identifying the coordinates of the given point. Now let's proceed to our next topic, which is relation. Relation is a set or collection of ordered pairs. The correspondence between two quantities composed of independent and dependent variables, whose value freely changes and does not depend on any quantity. When we say independent variable, it is a variable whose value does not depend on any other value and can freely change from day-to-day basis, while dependent variable is a variable whose value depends on the changes of the independent variable. Let's have some examples in identifying independent and dependent variables. Number 1. The number of workers working on a construction site and the amount of time it will take them to finish the construction. The independent variable here is the number of workers, while the dependent variable is the time to finish the construction. Second example, the area of a rectangle is determined by its length and width. The independent variables are length and width, and the dependent variable is the area. Take note that as long as the numbers come in pairs, then that becomes a relation. Let's have the different ways of expressing relations. First example, a student generates about 2 kilograms of waste daily. So now we're going to complete the table below, which shows how the number of students affects the amount of waste generated daily. The number of students will be our x variable, while the amount of waste in kilograms will be our y variable. So if a student or one student generates 2 kilograms, how about if we have 2, 3, 4, 5, or 6 number of students? If there are 2 students, the amount of waste generated daily is 4 kilograms. For 3 students, there will be 6 kilograms. For 4 students, it will be 8. For 5 students, it will be 10 kilograms. And for 6 students, it will be 12 kilograms. We will now express the given relation in different ways. We'll start with a table. All you have to do is to make 2 columns. The first column is x, and the second column is y. So if one student generates 2 kilograms of waste, 2 students generate 4 kilograms. 3 students, 6 kilograms. 4 students, 8 kilograms. 5 students, 10 kilograms, and 6 students, 12 kilograms. Now let's proceed with arrow diagram or mapping. We simply copy X and Y, and under that, we are going to write the values. X will have 1, 2, 3, 4, 5, and 6. And for Y, we have 2, 4, 6, 8, 10, and 12. So 1 is paired to 2, 2 to 4, 3 to 6, 4 to 8, 5 to 10, and 6 to 12. So this is how an arrow diagram or mapping looks like. Next is a graph. The horizontal number line is the number of students, and the vertical number line is the amount of waste in kilograms. If there's 1 student, he or she generates 2 kilograms. For 2 students, we have 4 kilograms. 3 students, we have 6 kilograms. 4 students, we have 8 kilograms. 5 students is 10 kilograms. And for 6 students, we have 12 kilograms. So this is the graph of the given relation. According to Dump and Run Incorporated, the average college student produces 640 pounds of solid waste each year, including 500 disposable cups and 320 pounds of paper. Colleges witness significant spikes in their solid waste at the end of school year. So as a student, how can you help in managing our waste? Going back to the relation which we have expressed in different ways, what kind of relation is it? The answer is one-to-one relation. Each value of x has exactly one value of y. If we are going to write the given relation in listing or roster method, the set of ordered pairs are 1 and 2, 2 and 4, 3 and 6, 4 and 8, 5 and 10, 6 and 12. We will now determine the domain and range of the given relation. But before that, we need to define first domain and range. Domain is the set of all x-coordinates or abscissas. Range is the set of all y-coordinates or ordinates. So in the given set of ordered pairs, 1 and 2, 2 and 4, 3 and 6, 4 and 8, 5 and 10, and 6 and 12, the domain is a set of 1, 2, 3, 4, 5, and 6, while the range is the set of 2, 4, 6, 8, 10, and 12. For our second example, let's have this. Blood relations are highly valued by Filipinos. Children are taught to love, respect, and care for their parents, grandparents, and other relatives. Anna, Elsa, and Mona are sisters. Their children are listed opposite their names. Under children, we have Andong, Ansing, and Andeng. Their mother is Ana. Next, Ella and Eman. Their mother is Elsa. And for the last set, Mina, Mocha, and Macy. Their mother is Mona. We will now write the given relation as table. Andong, his mother is Ana. Ansing, her mother is Ana. Andeng, her mother is Ana. For Ella, her mother is Elsa. Eman, his mother is Elsa. Mina, her mother is Mona. Mocha, her mother is Mona. And Macy, her mother is Mona. For the arrow diagram or mapping of the given relation, it will look like this. Andong will be paired to Ana. Ansing to Ana. Andeng to Ana. Ella to Elsa. Eman to Elsa. Mina to Mona. Mocha to Mona. And Macy to Mona. The relation is called many to one since 2 or 3 children have the same mother. The set of ordered pairs are Andong and Ana, Ansing and Ana, Andeng and Ana, Ella and Elsa, Eman and Elsa, Mina and Mona, Mocha and Mona, and Macy and Mona. The domain is the set of Andong, Ansing, Andeng, Ella, Eman, Mina, Mocha, and Macy. While the range is the set of Ana, Elsa, and Mona. For our third and last example, Amanda sells used books for her to raise funds for COVID-19 victims. The table below shows the year the book was published and the selling price of the used book. For the year 2016, the price is 30. For 2017, the price is 40. For 2018, prices are 50 and 55. For 2019, we have 55 and 60. And for 2020, the price is 70. If we are going to express the given relation as table, it will look like this. So first column, we have the year published. And on the second column, we have the price. 2016, we have 30. 2017, we have 40. 2018, 50. 2018, 55. 2019, 55. 2019, 60. And 2020, 70. For the arrow diagram or mapping, 20 is paired to 70, 2019 is paired to 60 and 55, 2018 is paired to 55 and 50, 2017 is paired to 40, and 2016 is paired to 30. This is the graph of the given relation. For the year 2016, the price is 30 pesos. 2017, 40 pesos. 2018, we have 50 and 55. 2019, we have 55 and 60. 2020 is 70. This relation is called one-to-many relation. The set of ordered pairs are 2020 and 70, 2019 and 60, 2019 and 55, 2018 and 55, 2018 and 50, 2017 and 40, and 2016 and 30. Domain is a set of 2020, 2019, 2018, 2017, and 2016. And the range is a set of 70, 60, 55, 50, 40, and 30.